Hello, I'm Matt Hatton. I'm one of the founding partners of Transforma Insights. I have about 20 minutes now to share some of our research on autonomous robotic systems. I'm going to talk about three things. Firstly, I want to talk about some learnings from real-world implementations of autonomous robotic systems. I want to talk about best practice for how you deploy those systems. And I'm going to talk about our view of the future for those technologies. If you have questions, we won't have time to take them as part of the presentation, but I'll provide my contact details at the end and you can get in touch directly with me. Just a few words of introduction of Transforma Insights. We're a technology advisory firm, providing market intelligence, market forecasts, databases, reports, custom research, and so forth. We are focused on the diverse technologies which sit under the umbrella of digital transformation. Really what we're talking about there is a set of disruptive technologies, be it artificial intelligence or the Internet of Things, all of which kind of coalesce and work together and ping off each other to create disruptive environments within which enterprises have to work. We tend to use the useful umbrella phrase of digital transformation, but really it's a whole host of different technologies, of which one is autonomous robotic systems. What do we mean when we say autonomous robotic systems? Well, this is a neat illustration of the types of robots that we're talking about. It shows two axes. Firstly, the extent to which they move. Are they mobile or are they static? And then the grade of service, are they industrial grade or commercial grade or more focused on consumer products? Today, during this session, we'll be particularly focused on the bottom left. Factory robots, surgical equipment, construction equipment, and so forth. And the reason for the focus is revenue. The consumer space, although it accounts for millions and millions of devices, Roombas and connected lawnmowers and so forth, really doesn't compare to the industrial space where we're looking at $40,000 maybe for a factory manipulation robotic system, which is what we're mostly talking about in the industrial space. There are some other interesting categories of vertical where there's some very interesting things happening. Warehousing, for instance, or remote surgery is another emerging space. I'll talk about both of those in a little while. Turning now to the analysis that we've done, well, the origin of it was a book written by my colleague Jim Morrish, who is one of the other founders of Transforma Insights. That book was called Enterprise IoT. And we can kind of think of autonomous robotic systems as living under that umbrella of IoT. And what he was doing within that book was looking at the parameters, the deployment criteria for IoT implementations, a whole host of criteria. That was enhanced and implemented by the Industrial Internet Consortium as a project explorer, which looked at trying to understand the project complexities and the parameters within which any given IoT application was deployed, in order to help people to look for other deployments that were similar to ones that they'd done. At Transforma Insights, we've taken that a step further. We've looked at other deployments of new technology in other areas, robotic systems being one, but artificial intelligence, robotic process automation, a whole host of other areas, with a view to better understanding how deployments work. For each of the case studies, we look at a set of solution characteristics. There's a generic set, things like time to deploy, or payback, or scale, or criticality. Others are specific to the technology family in which they find themselves. For instance, for autonomous robotic systems, things like deployment environment, whether it's indoor or outdoor, the degree of autonomy that device has, and so forth. So let's delve into the numbers a little bit. On the left-hand chart, we're showing payback versus deployment. Now, this is showing very different things for drones, which are one of our autonomous robotic systems devices, versus factory robots. For drones, 90% of investments or 90% of projects take less than 6 months to deploy, and most pay back in less than 6 months. Factories, in contrast, more than 90% take over 6 months to deploy, and more than 90% take over 12 months to pay back. So much more significant investment in those factory systems. On the right hand side, what we're showing is the impact. Is something that's deployed transformational? And is that transformational on process efficiency, which is the internal factor, or is it transformational on the value proposition, i.e. externally, does it have an impact on the products? Or is it impactful on the industry as a whole? Does it create industry disruption? And what we can see is almost all of the focus of these autonomous robotic systems are on process efficiency, changing an internal process. The implication being that it's rather playing it safe, not some of those additive manufacturing approaches which I'll come to talk about in a little bit, but it's much more focused on just doing the same thing that's always been done, but in a rather more efficient manner. We also look at risk and a number of other factors, but let's talk about risk first. The vast majority of these deployments have zero risk associated. They are, as I said earlier, doing the same thing, but maybe in a more efficient manner. This is slow and steady stuff. But quite a high proportion are mission critical, which you'd expect. These are, in many cases, the factory machinery that are fundamental to how the manufacturing organization might operate. So, although it might be slow and steady stuff, it is desperately important. Off-the-shelf products dominate. This is not a big customization project. This is a sector in which people buy products off the shelf, be that factory robots or drones or whatever. Now, that might change. I'll talk about that a little bit in a while. I also mentioned there were some autonomous robotic systems specific characteristics. One of those was degree of autonomy. You'll notice from this slide that for drones, for instance, the degree of autonomy is very variable. Compare that with the manipulation robots, where those systems are highly automated. This is partly down to regulation, we suspect. Drones are much more aggressively regulated than factory systems. The direction of travel for those factory systems, which have more leeway, is towards full automation. We would expect that also to pass into the drone space as well. So the direction of travel for all of this is towards much more automation, with possibly a few exceptions. Best practice, a few words about best practice. Start with mundane repetitive tasks. This might be fairly obvious, but the high volume repetitive tasks are typically the ones where autonomous systems can make more of an impact. It's things like suturing. That's probably the first medical application that autonomous robotic systems have been applied to. Or packaging or labeling, not in the medical sense, but in more traditional warehousing. Those kinds of tasks are very obviously ones that can be transferred to robotics. One of the big themes that comes across in the research that we do is the opportunity that's presented for onshoring as a result of this. Not only is that about lower cost, but it's also about more responsive manufacturing. The ability to take your manufacturing from a central space out to a more distributed space is clearly facilitated by having these autonomous systems. And then you think about regulation, another area to look at. This is focused much more on drones, so I'm not going to talk about it in any great detail, but it's worth noting that being aware of regulation is all part and parcel of a horizon scanning exercise, or a set of horizon scanning exercises, that any organization ought to be doing if they're thinking about how new technology might be disruptive to existing operations. So anybody should be doing horizon scanning, looking at the likely impact of regulation or any other factor, internal, external, competitive, and so forth, on operations. I mentioned earlier about technology implementation being complex. This stuff is difficult. There are a number of interesting ways in a number of different paradigms that are affecting the space, and it's worth unpicking a few of those. One is the concept of demonstration. This is the same process as used by robotic process automation to automate some PC tasks, but applied to the physical world, applied to robots. So you show something, show a task to a robot, and they pick it up, understand it, and eventually refine it and become more capable at it than the initial, well, either the person or the managed task. There's a lot of AI involved with this, and certainly a lot associated with the robotic process automation task, which I talked about just a second ago. RPA being tasks on a PC which are shown to a bot, which then can replicate and reproduce. So that kind of mentality is being introduced into the physical robotic world. Collaboration. The robotic world is becoming more of a software than a hardware market. This has got implications for vendors and vendor selection. So those vendors who are unable to make that shift to the hardware space will get left behind. 5G. Industrial is clearly the most interesting and exciting of the 5G opportunities. The low latency, almost to the point of being real time, means it's usable for all sorts of industrial applications and very valuable for them. We're seeing a lot more adoption of private networks within factories supported by 5G to run sense networks and run, monitor, control, and even actuation of robotic systems. And the orthogonal, additional revenue streams. This is always worth considering. What else can you do with a delivery robot than just deliver items? Worth thinking about. Now I'm going to turn to our forecasts. First off, some investment forecasts that we did earlier this year, where companies are investing money in robotics. Manufacturing obviously dominates, but we also see some interesting investment in the construction industry, house building robots, for instance. Also transportation, particularly around warehousing. Now this has become much more of an issue very recently because of the incredible reliance on efficient supply chains, necessitating more effective warehousing. There's also going to be significant investment in the health sector, associated with all the support tasks that robots can perform there. If we look at things from a geographical angle, it's interesting that the great manufacturing giant of China is not so dominant here as it is in many other aspects of manufacturing. A large part of this is because it'll be used as an excuse for onshoring. those autonomous robotic systems, will be used as an excuse for onshoring. This explains the strong showing for North America and Europe. Japan and Korea also score high because of their relatively high labour costs. They may have a strong position in manufacturing, but that will be also affecting a desire to make greater use of autonomous robotic systems. And we can't not talk about COVID-19. So I've pulled out some data from our recent TAM forecasts, specifically about the Internet of Things. This is a much broader set of forecasts, but I think it's worth pulling out the particular aspects of this that are related to autonomous robotic systems. Now, overall, this IoT market, the revenue is expected to grow just 5% in 2020 compared to 16% in 2019. And if we look at precision specialist robots, which is predominantly what we've been talking about today, that goes from 10% growth, 13% growth in 2019 to 10% growth in 2020. So not a tremendous impact on the amount of growth that's expected. Now, obviously one would have expected that growth to be higher in 2020 than 2019, but still relatively strong growth. Predominant issues being supply side, actually, not demand. So there is a challenge about supporting the amount of demand in an environment where it's very difficult to install or very difficult for the manufacturing process to produce these robots. Let's turn to the vendor landscape. The interesting thing here is the extent to which the intelligence which is layered on top of the hardware is becoming more of a requirement. Okay. Historically, we saw successful hardware vendors who could just limit themselves to that space, but actually increasingly the intelligence piece is an absolute necessity. And we would expect that to continue. And that has implications for anybody who's buying robotic systems. They should be thinking about and discussing and looking at what the capabilities are within any given platform that they're investing in. And that brings us on to opportunities and risks. Now, the big opportunity associated with autonomous robotic systems is obviously cost savings. A much more efficient way of running a business and can make substantial changes to the bottom line. Hence what I was showing in one of the earlier slides about the case from the case studies database about how the impact is very substantial on internal processes. But don't underestimate things like additive manufacturing and mass customization and the ability to be more adaptable in production. Okay. We will see much more of a demand for these kinds of capabilities, these kind of mass customizations and adaptability capabilities. Risk. I mentioned a ballpark cost of $40,000 for a piece of equipment for a factory. That obviously has a substantial risk associated with it. There's also a risk, though, of losing something in flexibility, of moving from a workforce which is based on people to one which is based on robots. Elon Musk himself said that he'd wished he'd used less automation within his factories. And there's a lesson, I think, there for all of us, that this is not necessarily a silver bullet. That's the end of the presentation. It was a very quick spin through of some of the research that we've been doing on autonomous robotic systems. If you've got any questions, don't hesitate to ask. You'll see my contact details on the slide here. I also recommend that you follow us on Twitter. Thank you very much for your attention.